Okay, so today we're going to talk about chapter 13, which is on Newton's laws, F equals ma. So let me give a brief overview of concepts before we start solving problems. Okay, Newton's third law says that the net external force is mass times acceleration, right? So external forces can be things like gravity, spring force, friction. It could also be the applied force. M is the mass and A is the acceleration. Okay, Fg is, let's say, the gravitational force. Then Fg is given as mass times gravity, which you know, where G is a constant, right? It is 9.8. meters per second square, or you could also write it in foot-pound system, which is 32.2 feet per second square. Spring force, I'll denote that as Fs, is the spring constant, which is a constant for that particular spring, times the net stretch in the spring. So that is L minus L0. L0 is the free length. That is the length of the spring when no force is applied, while L is the length of the spring when the force is applied. So the way to picture this is a spring with rest length L0. Once you apply a force, this spring is going to stretch. The new length is L due to the effect of a force. So there's net extension that is given by L minus L0. Was L0, then this is the extension, that is let me call it delta L, which is L minus L0. Okay, the last thing, by the way, this force always points in a direction which gets the spring back to its original length, right? So the force K L minus L0 is always in this direction. Or in other words, it tries to take the spring and get it back to its original length L0. Similarly, if I had compressed the spring, so for example, if the spring was here, this much, this long, by applying a force in the opposite direction, then the spring force KL minus L0 would be in the right direction to the right. So it will try to get the spring back to its original length. In other words, that force always gets the spring back to its rest length. The final thing I want you to know is the friction force. and I'll denote this as, let's call it FF. So if there's a mass on friction force, F, F small f. So when you place a block on the ground, the only force acting in the vertical direction is mg due to gravity. There has to be a force in the normal direction, because if there is no force in the normal direction, then the block would not be on the floor, right? It's not falling freely. It is held onto the ground by a force, which is the normal force. So in this case, if this mass is moving to the right, then there is a force which sort of opposes the motion of the mass to the right, and that force is the friction force. And the friction force is given by mu times n. So that's the definition of the friction force. It is a constant called the coefficient of friction times the normal. Okay, so that is the expression you got to use. Now in this case, what we do is we do force equilibrium in the y direction and the x direction. So if you do the force equilibrium, then N equals mg, because net force in y direction is 0, right? So, or you can say N minus mg equals 0. So N is upward, so it's positive, mg is downward, so it's negative, and the net force in the y direction is 0 because this mass is not moving in the y direction. So then you can take that N, which is equal to mg, shove it in the first equation and find the friction force. But when you're solving problems, remember to use this expression. The normal force will change depending on how the block is placed. So the first problem today we'll talk about how to find the friction force when the ground is not horizontal. Okay, the key to solving problems, and I repeat this every time I teach it, and people do not follow this, but this is very important, is to follow these 3 steps. And if you follow these 3 steps, usually you'll get it right. And if you do not follow these steps, then it is sometimes hard to solve the problem correctly. So here is how you go about solving problems related to F equals ma. Solving kinetics. So what we're doing in this class, F equals ma, is called kinetics. What we did previously in chapter 12 and 16 was called kinematics. There was no forces involved in the previous part, right? Solving kinematics, which is F equals ma, we got to do these 3 steps. One is draw a free body diagram. Okay, what is a free body diagram? Well, it's a diagram which shows all the forces acting on the particle in this case. And I'll call this free body. I'll denote free body diagram by FBD. FBD. FBD should show all forces acting on the body. Okay, the second step is write Newton's law, which is the same thing I wrote earlier, F equals ma. And you can write this in all directions. So F, there is a vector, so there's, in a rectangular coordinates, we have fx, fy, fz, and a is ax, ay, az. So you can write that equation in all 3 directions. sometimes you'll find that acceleration in certain directions is 0. For the previous example, the block on the ground, the force, the acceleration, the vertical direction was 0. So if that is the case, then you basically boil it down to a statics problem. You don't need accelerations. So once you do that, you would get the F forces from the first step. You will solve for the acceleration in the second step, and then this part is optional. It really depends on the problem you're going to solve. Um, if you're asked for, let's say, the velocity or the position, then integrate A, and you get this from step 2 to find V or R, right? So if you want to find V, you got to integrate that particular expression once, acceleration, and you need to integrate twice if you want to find position. So the first step and second step is something which is new. The step 3 you've done before in the previous previous 2 chapters. So the best way to illustrate these steps is to solve problems. So I'll start off with a very simple problem, and then we'll do some harder ones. Is this clear? Okay, so this is a 10 kg block, and if a 10 kg block is placed on an inclined surface, it's going to slide down, right, provided the friction force is small enough. So the friction is given to be 0.2. You're going to write the equations of motion, the x and y direction. So if you're told to write the equations of motion, if you go back to this 3 steps which I indicated earlier on, okay, you just have to do step 1 and step 2, because the step 2 is F equals ma. That's the equations of motion. Yes. Yeah. Okay, so here we got a choice of coordinate frame. We can either have the coordinate frame along the horizontal and vertical. In this case, it's beneficial to consider a coordinate frame which is sort of inclined to the plane. So x-axis is along the plane and y-axis is normal to the plane. So the first step is the free body diagram. So I redraw the mass, and I only show the figure for the mass. There's no inclined plane. Okay. Okay. So what are the external forces? There is gravity, and clearly gravity acts vertically down, like so. The mass is moving downwards. There's no reason why it will move upwards, right? So the friction force always opposes motion. It will prevent this mass from sliding down. So it has to act in a direction which is opposite, let me call that FF, opposite to the motion. Okay, the final thing is that this mass is not going to penetrate the ground, right? It's not going to have motion in the y direction. So there's some force which is preventing it from getting sucked into the ground, and that force is the force exerted by the inclined plane on the 10 kg mass. So there has to be a force N which comes from the fact that this mass is resting on the ground, or it does not have motion in the y direction. Is there any other force you can think of that I'm missing? Okay, so you should not show acceleration. So there is an acceleration, clearly it's going to accelerate in this direction. You should not show acceleration on the free body diagram. You only have to show the external forces. Okay, so this is the key, and I've seen that students will not draw this right. And that's the starting of, well, you get everything wrong, or you'll miss out something if you do not get this right. So it's very important to draw the force in the right way. Okay, so the second step is to write F equals ma for the particle or the block. So I do this step for the horizontal direction and the vertical direction. You could also write F as a vector. I just prefer to write it in the x and y direction. So let's write this as Fx equals mass times acceleration in the x direction. So we need to find all the forces in the x direction, where the x direction is along the inclined plane. The only force acting in the x direction in this case is Ff, right? As I've shown it in the figure there. Okay. Now Ff is acting in the negative x direction, like I've shown it there, right? So it's negative Ff equals mass times the acceleration. It's, yeah, it is at an angle, but my coordinate frame is inclined. So that force there will not be an angle here, because this x is along the inclined plane.
Or because you tilted your...
I tilted. Yeah, so I'm just tilting it because you see that the math is much easier. Question?
So the MA on the right side is the MG a little bit to the right compared to the first one?
Oh yeah, so I missed something here. This isn't completed. So Ff is not the only force, right? Because look at mg. Mg acts in the vertical direction. So you got to resolve mg in the y direction and the x direction. That's the force I'm missing there. So this isn't completed. I'm missing a force. I'm missing something else. So mg can be resolved in, well, first I need to find this angle. You know what that angle is? Can you?
What do you change your direction within? Is it easier to solve this problem?
It's totally up to you. You can assume x to be in the horizontal and y to be vertical. The reason I did not use it is because your acceleration is in the x direction and 0 in the y direction. If you have your coordinate frame this way, right, you're thinking, why not use this coordinate frame? The problem with that, well, it's not a problem, but you could do it this way. Only thing you'll have to do is the acceleration, which is in this direction, has to then be resolved in the x and y direction. I'm trying to choose a coordinate frame where I get the luxury of writing a as ax and ay in my two equations, and I need to only resolve forces, these forces. So if you use the other way, then you see that these expressions, the forces expressions become simple, but acceleration you need to find the sine and cosine. So you do not get anything for free. Both of the methods will involve resolution of forces, but irrespective of how you solve it, either that coordinate frame or that coordinate frame, your answers should be the same. You should totally try to do it. You can solve it with this way because you see that much easier. Okay, so I'm missing something here. The thing I'm missing is Ff acts in the x direction, but there's another force which is mg, which is acting. There'll be a component of mg in the x direction, right? Because mg is vertical. Right. So let's get to that. So I need to find this angle, theta. Let me call it theta. So the way I'll do this is, this line is the vertical line. This is my y direction. This is 90. This angle is 60, right? Because 60, 30, 90 makes it 180. So this angle here is going to be what? This is 90. So this has to be 30 degrees. So remember that this angle is always the same as the angle made by the inclined plane with the horizontal. I did it once in the exam. You don't have to do it. Like, you don't have to do this trigonometry here. You can just write it as theta. It should be fine. Theta, where theta is the angle of the inclined plane. So we can resolve this along this direction, mg cosine theta, and then we can resolve this in mg sine theta. So the force I'm missing is, as you can see, ff acts in the negative x direction. Then there's mg sine of theta, which acts in the positive x direction, and that's equal to mass times acceleration. So that completes my force equilibrium in the x direction. I need to do the same thing in the y direction. Fy is mass times ay. Okay, so what are the forces in the y direction, where y direction is normal to the inclined plane? Clearly there's an n, right, which is acting in the positive y direction. There's mg cosine theta, and it's got a negative sign. So those are the external forces, equal to mass times acceleration in the y direction. So the mass has no acceleration in the y direction, so it's 0. Okay, so in this case, ff is an unknown, n is an unknown. And then a is, sorry?
I think the question only was to find equation, right?
Equations, right? So you could keep it there, but I'm going to go a step further and find acceleration. So I'm going to try to find ax. Okay, so yes, so if you write this, you're good enough. This was a fundamental question, but typically in this question, you're going to find the acceleration. So I'm going to try to find the acceleration. So what I have here is 2 equations and 3 unknowns, ff, n, and ax. So I need to generate one more equation. So how can I generate one more equation? Yes, so you know something about ff and n. Ff is the friction force, is the coefficient of friction times n. And so let me call this 1, this 2, and this 3. So now you have 3 equations and 3 unknowns. Ff, n, and mu, ax. So I can solve for ax. So what I'm going to do is ff is mu k n equals, I'm going to use this expression to get mu k times n. N is mg cosine theta from 2, and then shove this in, put this in 1. So I have, so from 1 I can put ff there. So mu k mg cosine theta plus sine theta equals max, and then I can cancel off m. What I'm left with is ax is, I think I did a mistake, this should be negative. Okay, so this is g sine theta minus mu k g cosine theta, where theta is 30 degrees. So given the friction coefficient, given theta, the angle of the inclined plane, given gravity, I can find the acceleration of the block. So now another step could be, well, I could tell you to find the velocity after 10 seconds or 5 seconds, in which case you're going to take the expression and integrate it. So that would be step 3 of the algorithm which I told about, but it will be step 3. But in this case, you only stopped at figuring out A. Okay, is that clear? We'll do more problems and hopefully it'll be more clear. A slides from rest 20 feet down a smooth ramp. Okay, the key thing here is it's a smooth ramp, which means that there's no friction. No friction. Determine the point where it strikes the ground at C. Okay, you got to find the point where it strikes. And how long does it take to go from A to C? Don't think I need this. Okay, I need to find the time from here to here, and I need to find R. Okay, so this is one of the problems where it's actually a combination of two things. One is sliding along a ramp from A to B, and then from B to C, it's basically a projectile motion. You can think of it that way. So if I told you the velocity at B, right, the x and y component, you can pretty much find the distance r. You could also find the time it takes from B to C. So you do not need anything in this chapter to do that. That's something which you did in the previous chapter. What I need to do now is to analyze the motion from A to B. So I'm going to try to find, let's see, what do I have to find? I have to find the time it takes from A to C. So I'm going to find the time it takes from A to B, and then I'm going to find the time it takes from B to C by breaking down the problem into two parts. So A to B first, and then B to C. Okay, so let's start with A to B. Okay, so this is a Newton's law problem because you got to find, in order to find the acceleration or the motion of the block, you need to invoke F equals ma because it's sliding on an inclined plane. So we draw the FBD of the block. I'm going to assume that x is along the inclined plane, y is normal. Show all the external forces, so there's mg. Then if you want, I can draw this to be, well, this is 30 degrees, like I showed you last time. The angle made by the vertical or the normal to the inclined plane with the vertical, that is along the gravitational direction. And then I think that's pretty much, well, there should also be a normal force. I'm forgetting that. The mass is held onto the inclined plane through its interaction, which shows up as a normal force. So Fx equals mass times acceleration gives me in the x direction. So what's the net force in the x direction? It's going to be the component of mg in the x direction. So that's going to be mg sine theta. This is mg cosine theta, and this is mg sine theta, because I need to take this force and then resolve it along the x and y. So mg sine theta acts in the x direction, so it's positive, equals mass times acceleration. If I resolve force in the y direction, I have mass times ay. So the net force in the y direction is n minus mg cosine theta equals 0, because the acceleration of the y is 0. Okay, so in order to find the time it takes to go from A to B, I can do that if I have the acceleration, right? I know the distance. I need to get the acceleration so that I can find the velocity perhaps and then find the time. Now I do not quite need equation 2. This is not needed. This is the only equation which is needed. I just need to find the acceleration, right? So AX is G sine theta. That's all I need. So you notice that the acceleration is constant, right? G is constant, so is theta. So you could use some of the equations you had learned in the chapter on section on motion with uniform acceleration. So remember, x equals x0 plus ut, vt plus half at square, and v square equals u square plus 2ax, and so on. Those three equations. You could use them over here. So let's find the time it takes to go from A to B. Okay, so I could use S or X equals x0 plus v0t minus half a t square. Is that right? It's plus half a t square. Remember this formula? Okay. Again, I use this formula only because the acceleration is a constant. If acceleration was not a constant, I should not use this formula. So x is 20, right? It's 20 because given here, the initial position, let's assume that to be 0. v0 is the initial velocity is 0 plus half a is g sine theta t square. So 20 equals half. Okay, I need the gravity in feet per second square. So I think it's 32.2 times sine of 30 degrees times t square. So solving for t gives me, I get 1.57 seconds. Okay, so TAB, call it TAB. Okay, I would also need to find the velocity at B, because if I know the velocity at B, then I'm set up to find the time it takes from B to C as well as find the distance R. So I find the velocity at B. So velocity in the x direction, I could do it multiple ways. There are two more formulas which I have not used. There's a velocity as a function of x and the velocity as a function of t. So I'm going to use velocity as a function of x, vx0 square plus 2a x minus x0. So again, this is a formula you'd seen earlier, only applies when acceleration is a constant. So Vx is an unknown, initial velocity is 0, gravity is 32.2, sine of 30 degrees, and then x is 20, initial velocity, initial position is 0. So if I solve for Vx, get 25.37 feet per second. So another thing to note is that the velocity of the block is going to be in the x direction. The x direction is along the inclined plane. It's going to have zero velocity in the y direction. Y direction is normal to the plane. Yeah, question?
Why can't we use the other equation for the
Yes, you can use that. The reason why I did not use it is the following. Uh, if, if I trust this answer, it's that answer. But if I, in the exam, if I do not trust this answer, then this answer will show up in that expression, and my solution will depend on this answer. So by using this expression, I sort of use what is given 20. I do not use 1.57. That way I can sort of decouple my solution. So it's up to you. If you try to use, so he's saying, why don't you use Vx equals Vx0 plus AT 25. You should use that and see if you get the same answer. Okay, so I have this velocity, but this velocity is clearly in this direction, right? This is the velocity which the block leaves the surface. This velocity is going to be 0, right? It's going to be 0 because there is no force acting in that direction. In other words, the block leaves the ramp at an angle of, 30 degrees to the horizontal. So this is going to be 30 degrees. Okay, so given that, now I can start analyzing the motion from B to C using the equations from projectile motion. A ball, the typical problem we've seen, there is a ball launched. Either it will be launched with a velocity with respect to horizontal or vertical, right? In this case, Vx is actually the velocity with which the ball or the block is launched, and it makes an angle of 30 degrees. So you know the velocity in the horizontal direction is going to be Vx cosine of 30, and you know the vertical velocity, it's going to be Vx sine of 30, right? So don't get confused with the fact that I wrote Vx there. That Vx comes from the previous analysis of the previous part, where x was along the horizontal plane, along the inclined plane. So to find the time, how can I find the time from B to C? I can use the fact that the vertical distance is 4 feet. So let's analyze motion from B to C. So Vy, well, let me call this capital X and capital Y to distinguish it from small x and small y. So V okay, so the equation I want to write is y equals y0 plus Vy0t plus half a t square. In this case, it's falling due to gravity. Gravity is downward, so it's half gt square. So y is given to be 4. Initial position, let's assume that's the origin where the mass leaves. The velocity in the y direction is going to be Vx sine of 30. Say that again. Oh yeah, good catch. Yeah, it should be negative. This is also negative, and then half 32.2 t square.
Why is it Vs?
Yeah, so it's Vx because this Vx is small x and this x is the velocity with which the block leaves the ground. It comes from the previous part, so don't get confused by that x, but it's the absolute value of velocity. So solving for the only unknown is time. comes out to be, I get, so it's a quadratic equation. You should revise how to solve quadratic equation. The answer comes out to be 0.2413. You'll get two values for the time, and one of them I think comes out to be negative, and time cannot be negative, so you got to accept the other one, which is 0.2413. Okay, and the final thing to do is to analyze the distance r. R is, so I'm going to use x. R is simply x is equal to x0 plus vx0t. There is no acceleration in the horizontal direction, so it's motion under uniform velocity. So x0 is 0 plus the velocity in the x direction is going to be vx, cosine of 30 degrees times the time, which is 0.2413. It's from here. You know vx, so you can solve for r. R equals 5.3 meters. By the way, vx, this is 25.37. This is not meters, my bad, this should be feet. Okay, and I'm told to find the total time. So this is BC. So the total time is TAB plus TBC, and that comes out to be 1.8113. This is one, this is the second part. Okay, any questions? Okay, last problem. Yeah, cylinder B of mass M is hoisted using a cord and pulley system shown. Determine the magnitude of force F as a function of the block's vertical position, so that when F is applied, the block rises with a constant acceleration AB. Okay, so AB is constant. So you need to find F such that AB is a constant. Okay, so when you see forces in the problem, you have to think about Newton's laws. If you see, how do you distinguish from the problem in the previous chapter where you had pulleys, was you were given this point moves with a velocity of so and so, or acceleration of so and so. In this case, you're given forces, so you got to think of Newton's laws. So the first thing I do is draw the free body diagram for the mass. Okay, so there is a tension in the cable here, and then there is mg. Okay, so that is a free body diagram for the mass m. Then I'm going to draw a free body diagram for this, the pulley. Okay, there's going to be a force F and the same force F. Okay, the reason why the force is F and F is because this is the same cable which wraps around the pulley, and you know that the force should be transmitted. It should be the same force at either edge. That is true when the mass of the pulley is negligible. Okay, if the mass is negligible, the forces should be the same. So F is the force T acts vertically down. Okay, I'm going to redraw this over here so it might be much easier to visualize. We'll draw this way. Such that this is this pulley, this is this mass. Okay, this F is the same as this F because the net force, the same force, shows up throughout the whole pulley. Okay, so I think that's all I need. I'm going to write the equations of motion. I'll use the short form EOM. Okay, I'm going to use, well, I need to resolve forces, so I'm going to define theta to be the angle made by the vertical with the string as shown there. So let me call this figure A and this figure B. From A, what I can see is that 2f cosine theta is equal to T, right? This is a statics problem, right? Because the mass of the pulley is negligible, so all the forces should sum to 0. So 2f cosine theta acts upwards, there are two forces, and then T acts downwards. So from B, since this mass moves upwards, I can write T minus mg equals mass times AB. So put 1 in 2, I get 2f cosine theta equals T. This T is mg plus mab. Okay, so let's see. So I'm given A, B, G and M is known. F is the unknown and theta is an unknown. So I have two equations and one equation and two unknowns. So I need to find theta in terms of something I know. I know y, I know d. So let me try to find theta as a function of y and d. This is theta, this is d, this is y. So how is theta, d and y related? It's this is 90 degrees. So this is d divided by 2, right? So now it's simply tan theta, or well, I need cosine theta. Well, I can write tan theta is d divided by 2 y, right? So given tan theta, I can find cosine theta, or if you like, you can find this, the hypotenuse, that's basically y square plus d square 4 square root, right? So cosine theta is going to be the adjacent side, which is y divided by y square plus d square by 4. So all I need to do now is shove this cosine theta in the first equation and solve for f. So let me call this 3, call this 4, put 4 in 3 and solve for f. So f comes out to be mg plus ab divided by 4 I think there's a y here, y 4y square plus d square.
This cosine equal y over square root of y squared plus a squared over 4 or over y?
It's d square divided by 4 because this is, it comes from here. It's d, sorry. Okay, so we are about 70% done with your grading for exam 2. I hope that I will send it to you by tomorrow evening and we can talk about it on Wednesday. I think more people have passed the class. I just graded 2 questions and look like a bunch of them have already passed, like close to passing with just 2 questions graded. So we'll see.
Is there any way you could stand